So 1.7 is going to be a pretty short chapter, especially compared to 1.6. I think they're making up for the long lesson in 1.6. But anyway, it's pretty much just examples using things that we've learned at this point. Now, a couple of things I want to look at. This is top of page number 81. And a lot of times when you see things in the boxes here, you ignore them. But I do want to point out some things that are really, really important. And this isn't necessarily, I don't believe they're steps, but I just think they're things to keep in mind. So first thing you want to do, which I guess would be step one, is to factor out the greatest common factor. Look at the trinomial and see if there's anything you can factor out of there before you get moving with the rest of the problem. So for example, 81, example 1 has 2x to the 5th minus 8x cubed. So what you're looking for are things that will factor out of there, greatest common factors. And remember, you're going to look at the coefficients and see that you can factor a 2 out. And you're also going to look at the variables with exponents and find the exponent that is the lowest. And if it's common to all of the other terms, then factor that lowest one out. And then write what's left. We just got rid of the 2. We got rid of 3 of the 5x's, leaving us with 2. And we got out of a factor of 2. And we have 4 left. And the x cubed, we factored it completely out. So that's gone. And one of the key things, remember, when you distribute this back in, you should get what you started with. So that's kind of a check there. So as we're going on here, if the polynomial has 2 terms, so if it's a binomial like this one, then see if it is the difference of 2 squares or the sum or difference of 2 cubes. Okay, so those are your 2 options for having a method in order to solve these, like we did in 1.6. If they're not the difference of 2 squares, to where you can take the square root of the first term, square root of the second term, and there's a minus sign here, or if they're the sum or sum or difference of 2 cubes, then you can't follow that path we did in 1.6. You have to do it the long way. But remember, and I said this in the last section, if it is the sum of 2 squares. This is a square, you can take the square root of that. This is a square, you can take the square root of that. If this is a plus sign, it will not factor. And I mentioned that in 1.6 as well. So if this is a plus, you are done. You can't go any further with that, even though it looks like maybe you can. Okay, another thing you want to look at, if it has 3 terms, then, and it's a trinomial, then it is either a perfect square trinomial, which will factor into the square of a binomial, or it's not. Okay, those are your 2 options there. Most of them are not going to be perfect square trinomials. They will force perfect square trinomials in the book just because they want you to practice with it, but in real life, that's not normally the case. And remember, not all trinomials are factorable. That is, I'm going to say that's incorrect because they're all factorable. They're just not easily factorable because so far we've been trying to figure out how to factor them into 2 binomials. Not all of them can be factored using the methods we've done so far into 2 binomials. But as we go on further into the book, they will be factorable, just not in the same way that we're doing it now. If the binomial has more than 3 terms, so if it has 4 terms especially, but if it has more than 3, try to factor it by grouping. So that should be your key. Whenever you see more than 3 terms, look and see if we can factor it by grouping. And remember, we put the parentheses around 2 or sometimes 3 of the terms, and we can either factor things out and figure it out, or other methods that we have gone over in 1.6. So as a final check, see if there's any factors you have written that can be factored further. A lot of times we'll get an answer like this. Factored out the 2x cubed, this is what's left. Okay, yay, we're done. But we didn't look at, is there more factoring that can be done? Because this is the difference of two squares. So yes, there is more factoring that can be done. So our 2x cubed, whatever we factor out like that, if it's all by itself and there's no other factors outside of parentheses, that just kind of follows along with what we're doing. But because this is a difference of two squares, we can continue to simplify. Now, even though this looks more complicated than what we started with up here, because of the exponents and lack of exponents, it really is simpler. It is simplified. So just something to keep in mind when you're doing that. Okay, so let's get this out of here. One of the things I want you to look at here is 2x to the fifth plus 8x cubed. Now this is different than the last one because we have a plus sign there. We're still going to factor out that, but this has a plus sign, so that means we're done. We cannot factor any further because of that doggone plus sign. Okay, so let's continue on. Let's look at example 3. And all this lesson is doing is practicing these skills that you learned in 1.6. So it just has a lot of examples, and they're trying to tweak some things or confuse you a little bit when they're doing this. Not trying to confuse you, but just kind of giving you all the different options. All right, so first thing we're going to do, always, 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 factor. See if there's something that can be factored out of there, something that's common to all three terms. So I've got a 3 here, so I need to see if a 3 goes into 18 and 27. So I can pull that out, and then I look at my variables and my exponents on those variables. So I can pull out a 3, and that leaves me with a 1 here because I pulled out that 3. And this is a minus 6 plus 9. All right, and then I'm going to look and see if there's variables I can pull out. My smallest exponent is a 2. I've got 3 there and 4 there, so I'm going to pull that 2 out of there. And when I pulled 2 out of there, I have an x squared left. When I pulled 2 out of there, I've got an x left. And when I pulled 2 out of there, I have nothing left. So now I'm left with this here. And one of the things I am going to do, I'm going to get rid of this 1 here. That 1 really isn't necessary. Well, that 1 won't go away, so we'll just leave it there. There we go. Okay, so got rid of the 1. So let's see if we can, oops, wrong button. See if we can put or make a change to this trinomial here. All right, so 3x squared. Can I make this into 2 binomials? Well, first of all, I'm going to look and see if this is a perfect square trinomial, meaning can I take the square root of that? Can I take the square root of that? When I put them together, I get 3x. If I multiply that by 2, do I get 6x? Yes, I do. So therefore, it is a perfect square trinomial, which makes it a lot easier to do because I can do this. I can put an x here, a 3 here. So the square root of that, with this sign right there. And I put a 2 up here. And I'm done. Okay, so having a perfect square trinomial, being able to recognize it, makes it a lot easier than trying to do this. I mean, you can do this, x and an x. 2 numbers multiplied together give me 9. 3 and 3. Added together give me a negative 6. Therefore, they both have to be negative because negative 3 plus negative 3 is negative 6. So therefore, I get this. And then that can be written as squared because there's 2 of them. And we get the same thing. So it's not like if you don't follow this method of perfect square trinomials, you're going to get the wrong answer. It just means that there are other ways to find the right answer that are easier. So that's pretty much what we're looking at. So if you can't figure it out using Or if you forget, because that's pretty much the case with me, is I forget, oh, this is, to even look to see if it's a perfect square trinomial, and I do it regular factoring, not a big deal. It still works. Sometimes it just takes a little more time, but you know what? Sometimes you just get the right answer and you're happy with it. So 6a squared minus 11a plus 4, and this is example number 4. So the solution says here we have a trinomial that does not have a greatest common factor, so there's nothing in any of these that is common that we can factor out. So we're kind of stuck with it. So now we're going to factor it. And the book says we're going to factor it by trial and error. No, we're not. I don't like the trial and error method. I did it all through high school, and then I discovered this method, and it works, so I'm going to use it. This number times this number. Then I'm going to find the factors. So I've got 2 and 12. I've got 3 and 8. And I've got 6 and 4. I think that's it. And then I've got the pluses and minuses of both. So 2 and negative 12, because this is negative. Or I'm sorry, no, I'm mistaken there. Let's just leave that the way it is. I was thinking I needed to find two numbers multiplied to give me negative. It's 24, positive 24. So these are my options. So the only other option I can have to get me a positive 24 is if both of these are negative. So I can have negative 2, negative 12. And the only reason I look at the negatives is just from experience. I notice this negative 11. So I know that when I add these numbers together, I get a negative number. The only way I'm going to be able to multiply two numbers together and give a positive 24 and add them to get a negative 11 is if they're both negative. Two negatives multiplied give me a positive. Two negatives added together give me a negative. So that's telling me that this is the one that's going to end up working. So again, I'm going to write this as 6a squared minus 3x, or I'm sorry, a, minus 8a plus 4. Okay, so now I've got four terms here. I'm going to put them in grouping symbols, like that. And remember, a while back I said, when you find your two numbers here, if one of them is positive and one of them is negative, the negative should always go first and then the positive. But in this case, they're both negative, so it doesn't matter what order I put them in. But this negative here is going to cause me some headache possibly. So be careful of this negative and let's see where it goes. And again, I have not done this one, so that's why I said possible struggles as we get going. So, okay, so I'm going to look at this group, and I'm going to pull out what I can and write what I've got left. Okay, so remember, I took all of this out, but I always have that place value of 1 in there that has to be in there. Now I've got this one. I'm going to pull out a 4. That's all I can pull out of there. Oops, that's a 2a. And that is a plus 1. So I want you to look here. This has a plus. This has a minus. Cannot be that way. Both of them have to be minuses. So that's one clue that there's something goofy with this negative sign. The other thing is when you multiply these back together, negative 4 times 2a is negative 8a, and we have an 8a. So let's just look at the 4. 4 times 2a is 8a. 4 times 1 is 4. But this is a negative. So when I multiply this negative 4 times 2a, I get negative 8a. When I multiply negative 4 times 1, I get negative 4, and I have a plus. So in order for this to be a plus, I have to multiply two negatives. So I'm going to erase this negative, or positive, and put a negative in there. Now they're both the same. Now when I distribute, when I distribute this, I get my 8a and my 4 back, my plus 4, because negative times negative. Very, very confusing sometimes. So put together the things that are on the outside, things that are on the inside, and I get the right answer. Okay, one of the things I do want to let you know about this negative and the struggle here. I could teach you the theory behind all of this, but what I found out over the years is it just either confuses students more or they don't care about the reason it works. They just want to know that it works and how to make it work. Okay, so I think we're going to end up with 2 videos because I talk too much and we have some more examples to go through. So let me do example number 5 with you, which is the exact same thing as the last one. The only difference is instead of plus 4, it's minus 4 here. So one of the things that you need to know is this cannot be factored. Let's say that you do multiply the 6 times the negative 4. And you wrote down all of the options here. 2 and 12. Is there any combination of these that you can put together that is going to give you a negative 11 or an 11 at all? Because that's usually what I look at. Can I get an 11? And then we'll worry about the negative later on which one of these has to have negatives in a certain place to make this true. But there's nothing here that I can never add or subtract any of these terms here, these pairs here, and get an 11. So that means it's a prime trinomial or polynomial, and you can't really do anything with that. So we will keep going then. So it doesn't mean that you've done something wrong because you have no answer. Sometimes it means you just don't have an answer. All right, so that is 1.7a. We'll do examples 6 through 10 in 1.7b in the next video.